In this video, we are going to continue our work on number theory, and we're going to look at divisibility rules for these 5 numbers. There are divisibility rules for other numbers, and we're going to look at those in the next video. So you might be wondering why the divisibility rules even exist. Well, sometimes it's useful to be able to tell if one number divides another number without actually having to do the long division. So suppose I want to know, does 17 divide 1,734? Well, in order to determine that, I'm going to look at this number and I'm going to kind of pull it apart a little bit. That 1,700 in the front, I can have as a separate number plus 34. And then I can analyze each piece separately. So I know 17 divides 1,700 because we looked at in the last video, if a number divides another number, then that number also divides every multiple of that number. So 17 would divide 17 times 2, 17 times 5, or 17 times 100. All of those are divisible. All right, now I need to check this part. I need to check the 34. Well, I know 17 divides 34 because 17 times 2 is 34. So because I know 17 will go into this part and 17 will go into that part, I know that 17 divides 1,734. And this is actually a technique I used when I was grading your last videos. Remember when you set it up, it had to be true that this number was unable to divide any part of this number. So this is the technique that I used. I went across the number. 5 does not go into 3, 5 does not go into 32, 5 does not go into 324. So this idea is what I used as I was checking your last video. So some divisibility tests that work for smaller numbers. This would be something that we would just do by common sense. There's not a divisibility rule necessarily for 17, but we can analyze parts of numbers. On the other hand, there are some specific divisibility rules which we can memorize and can help us all the time. So in this case, a whole number is divisible by 2 if and only if its units digit is divisible by 2. Okay, so if you remember the units digit, that's the ones place. And this is saying it's divisible by 2 if the ones place is divisible by 2. And remember, if and only if reads the same backwards and forwards, or reads true backwards and forwards. So if the units digit is divisible by 2, then the whole number is divisible by 2. So if the ones place is divisible by 2, well, in the last video, what kind of numbers did we learn were divisible by 2? Even numbers are divisible by 2. So basically what this is saying is a whole number is divisible by 2 if the number is even. So we only have to consider the last digit. All right, how about divisible by 4? Well, if I want to know if a number is divisible by 4, I'm going to look at the last 2 digits. There's that same if and only if again. I won't go through it again, but remember that means it's true backwards and forwards. So the last 2 digits this time. So suppose I wanted to know if 4 divided this number. To do the long division on this number would take quite a while, but I only need to consider the last 2 digits. Does 4 divide 32? Yes. Then 4 will divide this whole number. I only need to check those last 2 digits. For 8, it's a very similar process, except I need to check the last 3 digits. So if I wanted to know if 8 went into that same number, I would need to check 532. So this one is maybe not quite as friendly for smaller children because you do actually have to do some long division here to figure that out. This one you probably know from memorizing your times tables. This one you know because you just have to know 0, 2, 4, 6, 8 are even numbers. So these two can be accessed by smaller children, whereas this one you do have to have some long division ability before you can do it. Now to help you keep these straight, one thing I want you to look at, 2 to the first power is 2. 2 to the second power is 4. And 2 to the third power is 8. So for 2, you just have to look at one number. You just have to look at the ones place. For 4, you have to look at 2 numbers. You have to look at the ones and the tens. And for 8, you have to look at 3 numbers. You have to look at the hundreds, the tens, and the ones. But looking at those exponents, looking at the powers of 2, can help you remember what those rules are. Okay, so let's put that into practice. Let's suppose I need to determine if this number is divisible by 2, 4, and 8. Okay, so you guys take a minute, pause the video, and figure out the answers to these 3, yes or no to each one of them. Okay, for 2, 2 does divide 97,128 because 2 divides 8. Remember, for 2, you only have to look if the last digit is even. All right, how about 4? Well, 4 divides 97,128 because 4 divides 28. 4 times 7 is 28. And how about 8? So this says 8 divides 97,128 because 8 divides 128. So you maybe not be able to tell immediately. And so what you would need to do for test or for quiz is you go on the side of your paper and divide it out. 8 goes into 12 one time. 8 goes into 48 6 times. Remainder of 0. So 8 does divide 128, which means 8 does divide 97,128. So even though you did have to do a little bit of long division here, it was a lot less long division than if you had to divide this entire number. It's just a shortcut for being able to determine if a number is divisible or not. Okay, how about this one? 83,026. Okay, pause the video, see what you think about those 3. All right, for 2, 2 divides 83,026 because 2 divides 6. Remember, for 2, we only have to look at that last digit to determine whether or not the whole number is even or odd. All right, how about 4? Well, 4 does not divide 83,026. Remember, we put the division symbol with the little slash mark through it. And the reason is because 4 does not go into 26. If I try to divide that, 26 divided by 4, 6 times 4 is 24, with a remainder of 2. So because my remainder is not 0, I can say that 4 does not divide 26. Well, how about 8? So I've got 8 dividing into 0, 26, which is the same thing as just 26, right? 0, 2, 6 has the same value as 26. And so I could divide this one in my head. I could remember my times tables. And this one also has a remainder of 2. So because the remainder is not 0, it won't work. So one thing I want you to notice, sometimes when 2 works, 4 is a yes and 8 is a yes, but not always. Just because 2 works, that doesn't make 4 automatically able to be divided, and it definitely does not make 8 able either. On the other hand, because 4 was a no, because 4 does not divide 26, I didn't even have to check 8. I knew automatically that 8 would not divide 26 because 8 is a multiple of 4. So if 4 does not divide into a number evenly, then none of its multiples divide into that number either. So I could say 12 does not go into this number, 16, or this big number right here, 12 doesn't go into it, 16 doesn't go into it, 20 doesn't go into it. No multiple of 4 will go into it because 4 itself didn't go into it. So yes might carry through, but might not, right? Just because this one is a yes doesn't make the ones that come after it a yes. But if this one is a no, every multiple of that number after it is also a no. Now, it doesn't mean that because 4 is a no, every other even number is a no, right? This has nothing to do with 6 because 6 is not a multiple of 4. Same thing with 10. But if it is a multiple of 4, then automatically the answer is no. If this number doesn't go into it, then none of its multiples will either. We could illustrate that with a Venn diagram. So if this first circle is all the numbers divisible by 2, every even number is in this first circle. Well, not all of those numbers are going to be divisible by 4, but some of them are. And then if we want to look at the numbers that are divisible by 8, we take these numbers that are divisible by 4 and say some of those are also going to be divisible by 8. Notice that this 8 circle is completely contained within the 4 circle. I can't have numbers that are not divisible by 4, but they are divisible by 8, right? The 8 circle is completely contained in the 4 circle, which means that for all of these numbers out here, these numbers were yes for 2, 2 divides these numbers, but they were no for 4, right? So yes does not carry, but no carries. These numbers out here that were not divisible by 4 are automatically not divisible by 8 because the 8 circle is inside of the 4 circle. Okay, here's our next one. A whole number is divisible by 5 if and only if the units digit, the ones place, is divisible by 5. Well, how can we tell if the ones place is divisible by 5? If you think about your 5 times tables, the ones digit goes back and forth between 0 and 5. So if it's any other number in the ones place, that number is not divisible by 5. The only numbers that are divisible by 5 are ones that end in a 0 or a 5. Okay, so how about 10? Well, 10 is a multiple of 5, so it makes sense that only some of these numbers would be divisible by 10. And turns out the ones that are divisible by 10 are the ones that have the 0. All the ones that end in a 5 are divisible by 5, but not 10. 10 is only some of these. Okay, so which one of these circles is correct? And do I have the Venn diagram correct on A, or do I have the Venn diagram correct on B? All right, well, let's experiment and see. Let's see if we can come up with a number that is divisible by 5, but not divisible by 10. Can you come up with a number that would go in this part of the Venn diagram? Sure. Any number that ends in a 5 is divisible by 5, right? It can go in that circle, but those numbers cannot go inside this circle. All right, how about down here? Can you think of a number that's divisible by 10 that is not divisible by 5? Well, any number that's going to go in my divisible by 10 circle is going to end in a 0. But I learned on the last slide that any number that ends in a 0 is divisible by 5. So this one is not correct. This is the correct picture. Every number that is divisible by 5 is not necessarily divisible by 10, but every number that's divisible by 10 is divisible by 5. This one is contained inside of this one. So let's suppose I had this number and I asked you if that number was divisible by 5. Does 5 divide this number? What would you have to check? Only the ones place. So what do you guys think? Does 5 divide that number? Yes, that number ends in a 5, so therefore 5 will divide that number. Well, how about 10? Does 10 divide that number? And the answer this time is no. 10 only divides things that has a ones place of 0, and this one has a ones place of 5. So how about if we did it the other way? What if I said 5, does 5 divide this number? Well, again, I only need to look at the ones place, and it is a 0, so the answer to this one is yes. Okay, let's try 10. Does 10 divide this number? Well, just like for 5, for 10, I only need to look at the ones place, and in this case, it's a 0, so the answer to this one is yes as well.